I'm again repeating it for those who have missed it something. As you can see what I have done over here. The first pin on this side, this orange color wire, that was coming in the first pin in this dip switch. So the first pin dip switch, as I will turn it on, you can see which segment it turns on. It turns on the G segment. So that's why the first pin I have called it as G. The second pin, which is connected with the second pin on that side, it is connected with the second switch, and as you can see, if I just turn it off, you can see which segment is being turned off. F is being turned off. If I just move it on, you can see F is being turned off. So this is called as F. The center pin over here, as I told you, this is common anode. So this is common anode pin. The next one is A, which means over here the next one is going to be A. So you can see as soon as I turn off the first one, or the third switch actually, this is coming out as A. The next one is B, you can see this is B. So this is G, F, A, B on the top side. And when I come on the bottom side, I started from this side over there. So the next switch was actually coming on over there, that was E. So when I turn this off, which segment turns off? E segment turns off over there. So let me just turn on over there. So this E segment, and then the next one is the D segment, because this is A, B, C, D. As I told you, this is A, B, C, D over here. So the D segment is turned on, and then the actually this is a little hard. And then the last one, this is segment number C. As I turn on this last switch, so this is segment number C. So I have written this as C over here. So this picture is telling me that you are actually going to have a 7 segment which has 10 pins, and what those 10 pins can do. This is the common anode point here, this is a common anode point here. This is G, this is F, this is A, this is B, E, D, C and data point. So these are 10 pins, and this is actually just a rough data sheet of each. Now this data sheet is still not complete, because I still don't know that what current or what color is going to be made of this one, but I just made this nomenclature of what pins are going to be done over here by each A, B, C, D, whatever. So this is a simple A, B, C, D, E, F. Now I'm going to use this one over here in my Altium design, which I'm going to just do now. Now I hope everyone of those who has the Altium installed over there, and their Altium is done. And actually my Altium is open on my laptop and my desktop at present. So I hope everyone, when you are going to open your Altium, this is going to be the main screen whenever you are going to have it. I hope everyone has it, and I hope everyone is going to use this while I am doing it in front of you. The next thing, you go on the file, and one thing very important, if your license is installed, then this screen is going to be visible. If your license is not installed, you will be given a notification in this area as soon as you will turn on this Altium software that it is having a license failure or whatever. That statement will be written over here where my mouse is hovering at present. Okay, coming on to this one, you will click on File, you will go on New, and since I want to design a PCB here, so I will click this PCB, and as soon as I will click this PCB, this black color portion is going to be visible. Now I want this to be a little one, so I have just dragged this one and I have made this one. Now this black color area is my working space. Now before I move on and do something else over there, first of all, first thing, since I am going to design something and that is going to be according to some scale. So the first thing first, you have to change the units. Now normally I will prefer the SI units. So how I am going to change that SI units over here? I am going to go on that design. This is the design tab. Go on the board options, and there will be a dialog box open. Now here the measurement units are in imperial or metric. Imperial means that you are going to use the units of mils. Now what is mils? We will talk about that later on when I will be discussing, but here I am using metric. So this is metric, which means that the millimeter is going to be my working unit over here for my whatever distances I am going to measure or whatever I am going to work. So this is board options. Next options which I normally use, I don't force you to do this one, is click on this grid, double click on this one, and this actually tells you that what is the step size, step X and step Y. What this means, when you are going to actually move or drag anything in this software, this works just like an AutoCAD or something software. If you have used, maybe even you have designed some clip art in your Microsoft Word, you must have seen that there is the mouse, with the touch of a mouse you can move anything. This one is actually telling you that how minutely you can actually move anything in the X direction or the Y direction. So here I want to use it from the minimus over there, so I am selecting 0.025 mm. Why this is one? Because when I am going to align some 7 segments or some transistors or some resistance, I want to keep my PCB very small in size. So I am just going to drag them very close to each other without violating some rules over there. So this is going to be 0.025. I will click apply, OK, click again apply, OK. And you can now, I hope this is changed. I changed this to, oh sorry, this one was metric, this one is okay. So you can see now when I'm hovering this mouse on this corner over here in this region, I have millimeter recorded over here. So you can see X and Y dimensions, they are changing, DX and DY, they are changing. Now this black color area is my working space, and here I am going to design my PC. Sorry. Now, what I have to design, I need over here a 7 segment. I need a dip switch. Now, whenever you are going to physically put something on your PCB and your PCB is looking something like this over here, you need some footprints. Now, what is the footprint? If you can see closely in this PCB, all these markings are actually the footprints of the components which are going to be placed on this PCB. I'm again repeating. All these markings are actually the part of that footprint on which you are going to place that component. So for 7 segment of this size, which is in front of here, this 7 segment is going to have a footprint. Now, this footprint or the footprint of this dip switch, this is dip switch. Why? Because I told you previously, a dip means dual inline packaging and the spacing between the pins is 2.54 mm. So this is a dip switch over there. Plus these resistances, these are axial resistances over here, because they have just 2 ends over there. You can just put one end in one hole and the other end in the other hole over there. So you need footprints for all these 3 components. For wires, you don't need any footprint. Why? Because they are actually going to be made up of copper, just like this PCB over here. And this PCB, as you can see over there, the coppers are sketched on this printed circuit board or the fiberglass or bakelite sheet. We'll talk about that over here, but just for now we need footprints, and for footprints you need libraries. Now, since you are just beginners in this Altium software, so you will be requiring libraries, and I will share libraries with you as this lecture goes on today. So the first thing first, you need to install libraries. Now, just for you people, I actually made this libraries totally vanished from this my Altium software. So I'm going to install libraries over here which I require. Now this which library is required, you will come on to it as the time goes on and as you will experience on this software. But just for now, how you are going to install those libraries, because those footprints are required. Since you need to install libraries, so you need to place a component. So we'll click on place, go on component, and on this component, when you will click the place component, you have placement type, a footprint or a component. Now I require a footprint. A footprint is something, as I told you, which will have some pads. Pads are the connection points which are going to be done on the PCB. So if I just show you over here, these holes or these circular ones are pads. These in this PCB where my mouse is hovering, I hope you can see this point. These holes which are drilled over here, and these pads which are going to be actually of copper, but they are actually now oxidized a little, so maybe they are a little dull copper color. So these are pads. So I need a footprint which will have pads and the component over there which is going to be. Now since I don't have any footprints over here, so I will need to add something. So I will click on this one. Now this gives me all the libraries which are by default included inside it. As you can see, I can see all the components which are already inside it. So this is a miscellaneous devices, and you can see all of these. You can see their names and all that stuff. You can see their picture. You can see this is a resistance over there. This is the shape of a resistance, but I will not use this one. This is axial 0.3, 0.4, 0.5, 0.6. These are just different shapes of those resistances. But I don't need to do that. I need to install some new. Now if I just click on this one, these are some installed libraries which are by default available inside this one. Now I need to install some libraries, so I will click on this one. Now these are available libraries. I need to install something. So I will go on the installed, and here I will need to select some libraries which I will give you in the later half of this today's lecture. So I will give you those libraries, but I have all my collection available over here in my, actually this is available on my E drive, and in my E drive I have them as Altium, let me just see, where is that, sorry, E drive, let me just check on, where is my Altium, okay, this is my Altium, and inside my Altium I have my Altium library. So inside my Altium library, I will not select any other bit. I will just select Altium library and on. And now every library is over here, available over here, that is required over here. So these are all the libraries available that are available, and I will install this one. Now I will select that library from, again this one, oh, sorry, this is Altium. I need to go in Altium actually. This is Altium library. And if I show you now, over here all the libraries are available. Now I need Pcb Footprints. So I will go in this Pcb Footprint underscore 110, and here in the options I will select all files. Now if you just scroll through all of these ones, you can see they are capacitors, they are chip inductors, they are connectors. CON means connectors over here. Then there are the connectors or high speed over there. Then CQFP is the packaging name. We will talk about in the later half after the midterm on this one. Then you can see there is the word written DIP LED display. This is actually the one I require over here. So DIP LED display I will be requiring. I will tell you which library, which component I require from that library. So you can see this is a dual inline package. From here I will require the package for my DIP switch. So here I have lot of these libraries, and I have collected them over here, and all of these libraries I am going to install. I will give you this whole folder in zip format available on my website, or I will make this available on Sir Bilal's website also. So I will just select all over here and Control A, and will just click open. Now when I do that, actually some other files txt are also included, so I don't want them to actually be included, so it will just ask me 4 or 5 different times. And now you can see in this installed libraries part, I have these red ones are not libraries actually, these are schematics actually, so I'm not concerned with that one. I'm concerned with this PCB library extension, PCB LIB extension. So this is axial lead diode, BGA or CAN or whatever, all libraries are now installed over there. These are Protel footprint libraries over there, and I can just close them. And now all of those libraries are now available in this hovering. So this slider, I have all the libraries that I require. Now the first footprint I require is going to come from DIP LED display. Now these are alphabetically arranged, so I will just go on D. So I require DIP LED display, DIP dash LED display. I will select this library. As soon as I will select this library has a lot of 7-segment displays. Now the 7-segment display which you are seeing over here, this has a length, this length where my mouse is hovering is approximately 14.3 or 14.27 mm. So when I will go on Altium, I will have to select over here, now this will come on as time will come on, but here I will have to select LED dip -10 / 14.27 RHD. RHD means right hand letter over there, because as you can see this is a little tilted, it's coming on from the other side, so this is RHD. So in the Altium, I'm going to install this one, click OK and click OK. Now what happens? As soon as I will click OK, you can see what is happening. On my mouse, I have a 7-segment display, and as soon as I will click, it will be placed on that black space. I only want 7-segment 1, so I am going to have this one as escape button, and only one will be placed. Now as you can see over here, I don't want another one. I will just come on it later on for the other segment. So this is cancel. Now I want to just zoom in and see that the same 7-segment, what is the footprint. So I will go on this bar. This is actually a zooming tool. So I will just go on this one, make a zoom just like you do it on your mobile or whatever by your fingers. So you can see now this is a 7-segment. This is a 7-segment, and if I double click this footprint, you can see the name written over there. This is LED dip /10/14.27 RHD, and this is having row spacing 15.24 mm, and you can see all of them are 14 points. So this is 14.27, 10 leads, just like I told you, this 7-segment which you are using, it has 10 leads. So this is again that one. So I am using this one, 14.27 RHD. So this is OK, close. So now I can just double click this designator. This is just a name given to it, and I can call it, supposingly, I'm just going to write something. So this is I'm just going to write 7-segment. So you can see now this is 7-segment written, and you can see now this is pin number 1, 2, the center pin, which is the common anode. This is the other one, this is the other one, this is the other one, another one. So you can see now the 7-segment with 10 pins is placed over there. And now when you want to come out, this is actually zoomed in, I want to come out, press the control button and use your mouse scroll button, and you can come out very easily from here like this. This is actually my mouse scroll is actually not working. Let me just change my mouse. Actually I have 2 mouse over here. So okay, so I have this mouse now. So okay, so you can see now by using the mouse scroll button I can zoom out or zoom in. Plus you have this over here as well. This zoom fit document, whatever you have placed on over there, it will fit in. But I don't want to. I actually want to place some more components over there. So I'm going to have it like this. So this is a simple 7-segment placed over there, 10 pins, just like I have done physically a 7-segment over there on a breadboard. Now the next thing, I need a dip switch. Now for dip switch, again I will go on the place, again I will go on the component bar, and this time I will go on and I will have to go on dip. Now what is dip? As I told you, I need dual inline package. So I will go in dual inline package.pcb library. And as soon as, now one thing very important, it takes time. My PC is at 8 GBs of RAM, but still it requires some time. So don't worry on this one. So this is dual inline package. And here you have lot amount of components available. So now what I require something, let me just show you. The description actually gives a little bit more idea. You can see there is dip 8 pin, there is 10 pin, there is 26 pin, 24 pin. How much pin I require? If I go on this one, you can see how many pins are there. There are 8 on this side, 8 on this side. So I require a 16 pin dip. So I will go on the Altium again, and I will scroll down, and here there is dip 16. So you can see now the same picture, just like a dip switch. And what is 16 pin? This is 16 pin. Row spacing 7.62. What is row spacing? This is that distance between from this pin to this pin. From this pin to this pin, this is that distance over here. So it is 7.62. Pitch 2.54. What is pitch? The distance between any 2 pins, and that is actually the nomenclature of a dual inline package. So dip 16 I require. So now I have this dip 16, select this one, click OK, click again OK, and now you can see as my mouse is hovering, I have everything on my mouse click. Now, if I want to place this one in this direction, or I want to rotate it by 90 degrees, I will press spacebar. It will be rotated. Again, I will press spacebar. It will be rotated again 90 degrees in the clockwise, anti-clockwise direction. Again, I will click it over here. Again, it is going to be clicked like this. Again, mouse oil. So I'm just going to place it just like the picture we have done on the breadboard. So here it is like this. And as I have placed second one, I don't require the second one because I only have one dip switch. So I will press the escape button and it will be cancelled. So now I can change the name of this switch. I can call it as dip switch over here. So now you can see this is our dip switch over here, and in this dip switch you can see a 7 segment and a dip switch now. Now this 7 segment and this dip switch, they are going to be connected through wires, and then at the end you will require a resistance. Now that resistance is going to be again a footprint. So again I will go on the place, components, again I will go in the library, and this time I will go in the resistance axial library. I will scroll down to R, where R is there. You can see this is resistance axial, resistance dash axial. Now here in this library, you have a lot amount of resistances with different lengths and widths. Now our resistance, as I have used over here, is very small. So I don't need to be very specific on this one. So I will go on, I will just reuse something, this one, which is having a body of 8.5 cross 3.3. This is still enough. I'm just using it. I can use a little bit 7 into 2.8, but what happens if you do that, these wires over here, they will not be used over there. Just the resistance body will be used over there. So I'm just going to use this 8.5 into 3.3 mm, that is the length into the dia. So this is the length 8.5 from this pin to this pin, and from this pad to this pad, and the dia is 3.3. So I will just click OK, and you can see now I have a resistance on my mouse click. Now I require 8 of these. So what I will do now, I will do click 1, then just click close to it. I will have it as again. Now one thing very important, let me just zoom in and I will tell you what I am doing. If I place it very close, let's see, if I place it very close, the other one turns green. This is telling me that there is a violation of some rule. I can't connect them very close to each other, otherwise they will be physically touching each other, and by some chance they actually touch them and they are conductive, there will be a short circuit and it will be catastrophic. So the software is actually telling me that please keep some distance over there. So I am just now going to keep it here. This is the second one, and then this is the third one. I'm just going to keep it here. This is the third one. Now I don't want all these designator names to be coming on. So what I'm going to do, let's just see. Instead of placing 8 ones over there, I'm just going to click on this one, hide these. I'm just going to click this one and hide these, and again I'm going to click this one. I don't want these names to be written. Now this yellow color names which you are seeing over here, this dip switch and this 7 segment, they are actually coming on from the same thing which you are seeing on this side. This PCB, I told you in the previous class that this silk screen printing. So this yellow color marking which is on this one, this yellow color marking is the same silk screen printing on this PCB top side. This actually tells the solder person who is actually going to solder that you are going to connect which resistance where or which component where. So now I am going to just place, how I am going to just place, just see this one. Sorry. So this is my resistor. I will just select it with the mouse click. On my keyboard, Control C. You can see the mouse changes. This means whatever component I am going to select by this one, it will be copied like this, just like you copy anything in your mobile or your computers. And then I can just click on the black area and then Control V, and I have now everything. So I can now place it. Now you can see as I have placed it very close, they turned itself into green. So taking it a little far, so you can see now again I can do it over here like this. So this is, you can see again I have placed it a little closer. So then another one. So this is 1, 2, 3, 4, sorry, how many? 6 over there, 2 more. So this is going to be 1 more here and Control V again, and this is my. So if I just zoom out now from the whole picture by again Control and zoom, scroll out from your mouse, so you have this now. So what is here? I have a dip switch which I can rearrange over here, and I have a 7 segment over here which is named as like this. Now if I go back on my camera, what I require more now from it, I require an LED and a resistor, but for time being I'm not going to add them over there, but I require a block connector. Now I require a block connector to be working over here and here, so that are actually the positive and the negative terminals of that PCB, whatever I am designing over here. So I require block connectors, and for block connectors I am going to use, let me just actually see from where I am actually going to use the block connectors. Block connectors are actually going to be coming on from the PCB jack library. Now this library is not available standard. This library I have made it myself. So this is PCB jack library. Let me just see where is my P actually. Let me just find it out. Where is my PCB jack library? Actually this is not visibly available over here. Let me just check on over here. Where is P? Actually there is nothing available with the P one. Let me just check on. It should be here in this library. Okay, yes, one thing, sorry. In Altium library, these libraries are my made. One thing, sorry, I missed this one. Now, I imported everything from Pcb Footprints underscore this 110209. Now, block connectors, there is not an available library available, so I have made some components myself, and you can see these are available over here. So, now I will actually now import from here a PCB block connector. You can see this is a PCB block connector or a PCB jack. I actually want a PCB jack. Let me just see where is my PCB jack library. PCB block connector. Let me just check on. Actually, yes, sorry, yes, this is the same block connector. The name is changed. Actually, you can see this is a PCB block connector, and I will import it over here, and I will just place it over here in this one. This is my 5 volt. Now, since it has 2 pins, you can use one as 5 volt, other one as ground. If you don't want to use, you want to use the both as that one. So this is going to be positive here, the topmost, and the ground as this one. So now over here, I can call this one as 5 volts over here. For this block connector, this is actually a text. I will just make that one over here. No issues on that one. This one is going to be ground. So this is ground. So you can see now all of the components which I require, the footprints, they are available now in the Altium workspace over here. Gee, any questions up till now? Okay, let me just check actually. Please write down, let me just check on the. Okay. Actually, I have to turn off this MS Teams. Actually, they have normally. Bilal, please handle all these questions over here. I hope you can do that. Okay, 5 volt A, B, C, D, E, F, and all these are done. So if I just move on the camera now, so you can see now I have every wire which is connected on the top side named in my software. Now there is going to be a wire connected from this switch to the resistor end, from this second switch to the resistor end, from this third switch to the resistance. And they have to be given some name because these wires are going to be connected on the PCB. So I am going to give them names because these are now A, B, C, D, E, F, whatever their names. So what I will do I will give them a name such as A and underscore I can write switch. Now switch is a big word. So I'm not going to write whole switch. I'm just going to write A underscore SW over here. Next one. B underscore SW, C underscore SW. Please remember, these names are totally up to you, but please avoid 1, 2, 3 or A1, A2 or something like that. The names should be something very clear so that you can actually have them understandable when you are actually marking them. So next one, D underscore SW, next one is E underscore SW, next one is F underscore SW, the next one is G underscore SW, and last one DP actually underscore SW. So this is okay. Now you can see with A SW, B B SW, C and everything you have got everything. So almost all the nets are defined. Now these nets have to be connected with each pads. This is very important. Now each one of them has to be connected with pads which are on your footprint. I will just close this one. Now one thing very important, listen to this very carefully, this software is cracked. So normally it can have its working crash sometime. So please always save all your files whenever you are working on this one, and please press Ctrl S during all your processes so that it does not get lost, because previously I have got many mails previously in the previous sessions that they started work and they have done almost 80% of the work and then it got lost because there was a light failure or maybe the software crashed or something like that. So please have a habit, as soon as you make a file, save that file so that it does not get lost. Now coming on to this one, now since these are pads and I have to connect these pads with the nets. Now as you know, on this dip 7 segment, this one is G, the first pin is G, the next pin is F, the next pin is common anode which is actually 5 volts, the next pin is A, the next pin is B. So what I will do, I will zoom in on this 7 segment, double click on actually the first pad. I will just click on, you can see the whole pad is there. Out of all this pad, I have to, if I want to change the size, X size, Y size, I can do it over here as 2 mm and 2 mm. Please, one thing very important, all the pad size which you are going to design, they should be of 2 mm and 2 mm. By default, you can also change them whenever you are going to have them over there. I will tell you later on, but just for now, change it to 2 mm and 2 mm. The whole size is 0.9 or 0.8 mm roughly. But the one thing which I want to do over here is the net. So I want to connect it with which net? When I will click on this one, all the nets which I had defined, they are available now over here. So I have to connect this one with G. So I will connect it with G and click OK. So now this is connected with G net over here. And if I just zoom in over there, you can see there is G written over there as well in the center. So this is telling me that this pad is connected. You can see the size is also increased by whatever it was previously. It has now 2 mm, 2 mm. The next one, as I all know, if I go back over here, this is F. So what I will do, I will now again change this to 2 mm, this to 2 mm, and I will change this to, this is F actually, so this is F and this is F, changed over there. And then the next one is common anode, which is going to be connected to 5 volts. So I will again change the X size, the Y size, and here I will connect it with 5 volt directly. So this is 5 volts over here. And then the next one is, if I go back on my diagram, this is A and B. So I will just do it fastly now so that I don't waste much time over here. So this is 2 mm and this is 2 mm. You can see this is A and I click OK. And then this is B. So I will just select B over here. This is 2, this is 2 and click OK. Rest of the values, they are not important at present. So you can see all these sizes are changed and I have connected them with some nets. You can see this is G, F, 5 volt, A and B. So now I will move on the lower side of this one. On this side, this one, you can see this is square shape. Now, we don't want it a square shape. It's totally up to you. I want it a circular shape. So I will change the shape back to round and I will make it 2, again 2, and just to verify, this one is E. So this one would be E over here. like this and click OK. You can see now this is changed to the circular shape. The next one, let me just confirm it out. This is D. This is D over here. Changing the pad size again to 2, to 2 again, and then the center pin. Now one thing very important, this center pin and this center pin, they both are connected internally. So either you connect the topmost one or the lower one, same thing. So I'm not going to change anything on this one. I will just again go on this one. So this one is C. So this one is going to be C. This is going to be 2, 2, and this is okay. And the last one on the 7th segment, this is my DP. So this is DP. Changing the pad size to 2, changing the pad size to 2, and over here. You can see now all of the 7 segment bits or pads, sorry, they are now connected with nets. Now coming on to the dip switch. As you all know, the topmost side is going to be connected with the dip switches over there. Now on breadboard, you connected the first one with the first pin, second switch with the second pin, third one with the third pin. But since you are designing now a PCB, you don't need to do that, because I did it over there, because on the breadboard it was easy for me to take the wires from the first pin to the first pin, second pin to the second pin, then from the fourth pin to the fourth pin, then from the fifth pin to the fourth pin over there. Now over here on my on the PCB design, I have over here switches, and I am now going to make them as A, B, C, D, E, F, G and DP. So what I am going to do now, I am not going to make them as first pin over there, because this is a PCB. I can now design it according to my calculation. So I am just going to call it A. I am not going to change X size and Y size, and at the end I will tell you a way you can change all the pads on your PCB to 2 mm cross 2 mm. I will show you afterward. So this is A. Now as soon as I have clicked this as A, you can see what has happened. There is now a connection from this pin to this pin, and this is that line. So this net is that wire that we have done on this hardware over here on this one. So this one is that net. Now next one, this is that B. So let me connect it. You can see B. Then I will do the next one. This is C, and then this is that D. Sorry about this, but D. Then this is that E. And this is that F, and that is that G. So these are just the wires which I am connecting. Now these are just wires which are just telling you that they are going to be connected like this, and the last DP switch which is going to be DP. We have done that one also for this PCB. So this is that DP. So now you can see what has done. These are some transparent lines, or actually opaque lines connecting over there, telling you that when this software is actually going to design a PCB for you, this pad is going to be connected with this one, like this. Sorry. Now you have connected everything over here. Now the resistors turn. Now since, as I have shown you, that these switches are going to be connected with each one of these resistors, and the other end of these resistances are going to be commonly connected to ground. So what I am going to do, all these resistances are arranged together. I will click on this one, click ground, okay, click on this one, scroll down, ground, click on this one, on this, ground, click on this, double click actually, sorry, and this one, ground, and this one, double click, and this one, ground, double click on this one, and this is ground, this is double click on this one, this is ground, and double click on this one, so this is ground. So you can see now every common pin has now grounded over here. Now I have to connect this one with this one, and what is this? This is A, this is B, this is C switch, this is D switch, E, F, G and DP. Now here A was on this side. I have to use the net over here A underscore SW, because switch on the top. So this is A under. I could have named it anything. I could call it A1, the next one B1, C1, but here I have used it as A underscore SW. This is just variable which you are defining out. So this is A underscore SW. One thing very important over here, since the dip package is in front of you, you can see very clearly over here, the first pin is having square shape. This is telling you that this is pin number 1 of any dip, 2, 3, 4, 5, 6, 7, 8, then 9, 10, 11, 12, 13, 14, 15, 16. Now next time when I will give you a IC which will be in dual inline packaging, then I will tell you its data sheet and all that stuff over there. So this is going to be 1, 2, 3, 4. At present it is having no pin configuration because it is just simply a dip switch which is having 8 switches over there which are connected serially over here in series. So it is nothing fancy over there. So this is A underscore SW. You can change the shape to round or whatever. It's totally up to you. No fancy thing over there. Next thing is B underscore SW. The next thing is C underscore SW. The next thing is D underscore SW. The next thing is E underscore SW. And next thing is F underscore SW. This is G underscore SW. And the last one, which is DP underscore SW, which is data point. Now since if I zoom in, you can see every pad has now a net connected. Now the other side of this is the resistance. I will double click again on this pad, and here this will be A underscore SW. Now you can see the nomenclature is very easily done over there. Then next one, this is the B underscore SW. Then this is the C underscore SW, this is the D underscore SW, and this next one is E underscore SW. I have to click this one. This is the F underscore SW, this is the G underscore SW, and the last one which is DP underscore SW. So you can see now what I have done over here, this 7 segment is connected with this dip switch and the resistances. Now the only thing remaining in this PCB is the block connector. Now since block connector is going to be ground connected over here, so what I will do over here, I will just click on this one and connect this one with ground. Now since both of the pins are connected with ground, so you are going to have this one as ground connected over here, and the VCC is or 5 volts is actually going to be provided from this block connector. So this block connector, both 5 volt. You can only use one block connector also, but then this will be 5 volt, this will be ground, and then you have to be provided over there. Now you can see the PCB now in front of you. It has no tracks at present. Tracks mean the layers which I have shown you previously. This tracks over here on this PCB like this. So these tracks have now to be formed. Now since you are just beginners in this one, the tracks are going to be made in such a way that they have to be having some minimum width. Now what is that minimum width for you at present, since it is going to still have 10 milliamperes or 20 milliamperes of PCB, of current over there. So I am going to ask you to have a minimum width of this one, this track equal to 0.8 or 0.7 mm. Now practically your motherboards, your mobiles or something, they have the track width equal to 0.1 or 0.2 mm also. But practically this will be very difficult to actually make that PCB in the lab or anywhere. So and the current is also very large in our case because this is copper. This is copper on it. Practically it will be a PCB, a printed circuit board, which means it will be a copper sheet, and we are going to emboss, or wherever the extra copper is there, we are going to etch it or remove it. That process I will share a video in my YouTube channel. There is also a video on how to make a PCB, a single layer, so you can visit that one later on. But over here I am going to fix a rule over here. Now how those rules are going to be defined over there, I will go on this design, go on rules. Now this is a very broad rule category over here, but I want to actually just go towards the electrical rules over there, which means I want to actually have the routing or the electrical rules. Now when I click on this width, since I want to click on the width, I have top layer and bottom layer. Now standard procedure is this, that there is always going to be a top layer and a bottom layer, a double-sided PCB. At present, our emphasis is only on one layer. So this means I am going to design a bottom layer PCB, which means I am going to design something like this, which has tracks on this side, but on the other side components are going to be placed. Because this is a very simple PCB, no need of actually putting in effort and making it a double layer PCB. But yes, a double layer PCB can reduce the size of the PCB considerably. So here I am going to only change the size of my bottom layer. So my minimum width I have is 0.7 over here. Preferred size is also, you can call it 0.7, and maximum size is 0.8, like this. I'm not changing anything on the top layer. Top layer is always coming in red color. I'm not concerned with that because I only want to design a PCB with one layer. So I will click apply and click OK. Now everything I will ask this software to actually design this PCB for me in single layer, which means I have given the connections. It will read. not recorded or whatever. Don't worry. I'm just going to complete it in the next 10 minutes, and then we can just leave it on. Okay, coming on to the software. Back to the software. What I have done, you can see I have shared this all overall, and this PCB has been rerouted by this auto route button. I will just click on reroute and just undo. Okay, this was that point where all the filters have been done, the pads have been changed to 2 mm and all that stuff has been done. Now I want to route it. I am going to ask the software to do it for me. So for this purpose, I will click on auto route, click on all, and click on edit layer directions. Here top layer I am not using it, so I have select not used. For bottom layer this is automatic, and click OK. Edit rules I don't need to do it because I have already given it a size of 0.7 mm. So I will just click apply. I have already done it. So I will just click on route all. So as soon as I will click on route all, the software is going to do it for me, and you can see it's a very small PCB. So it has done it very fastly. So routing finished with 0 contention, which means there were no errors. Sometimes the PCB is big and you are asking it. Just wait. Just wait. I hope you can hear me out now. Yes, this is being done. Okay. Actually, the handy cam was actually the problem. Okay, anyway, so this PCB is rerouted over here. So what I'm doing now, I'm just clicking on this one and dragging it and trying to, because these are very close. So when this practically this PCB is going to be designed, this is going to be very difficult to actually make it. So I just made them in the ample space over there, and this one is also done like this. I can make this one track a little like this, and on this side also I can make it like this. So you can see, and on this block connector side, there is this switch over here, and in this switch I'm just trying to make them a little far apart. So like this, and on this side like this, and on this block connector under it I'm trying to make this PCB which is a little, now the tracks should be a little distance from each other. The software has given it a little close, so I am just trying to make them a little far, and just for now I can make this a little far from this one. So now you can see, I can just click save, and you can see the PCB is almost complete. And now since these block connectors here and here, they are actually going to be taking a lot amount of current, so I will have to thick the wires. So what I am going to do, I am going to place a fill area. This is a fill area, and I am going to just place them, it should be in bottom layer, so I am just going to click bottom layer from here, click on fill area, and this is going to be my fill area, and similarly fill area on this side. Now why this is so, because this is going to have a large amount of current coming in, and this one is also going to have a large amount of current coming in. So you can see now, and one thing very important, please avoid these 90-degree angles in your PCB design. These are not good, and when you are going to work on this one, please have a habit of not making any designs in 90 degrees. 90 degrees are bad in PCB designs over there. So whenever the wires, this one is also 90 degrees, so I'm just going to make them, in fact this is a little, so like this and like this. Why 90 degrees? When we will design a little bit complex PCB, I will tell you in detail. So this is a simple PCB. So you can see in Altium software, with the help of these libraries, I have designed a simple PCB. Now one thing you can do over here is actually the last thing is the margin. So what I'm going to do over here, I'm just going to click on this one. This is the interactive route or simple track over here. So I can use this one, click on this one and make a small margin on the sides. And let me just make this one. Now this margin is not going to be made in blue color. It has to be made in a layer which is going to be called as keep out layer. Let me just complete this. Just drag it and complete it over here like this. Now over here, double click on this one, a dialog box open. Here this is already by default in bottom layer. Click on this one and move, call it keep out layer. As the name suggests, this is the layer of the PCB which is keeping out all the other items. So everything inside this one line is going to be in pink color. So this is that pink color PCB over here like this. So this is again keep out layer, just doing all the 4 sides in keep out layer. So these are some layers defined. Today we have talked about the top layer and we have talked about the keep out layer at present. So this is a simple PCB of the same circuitry which we have just done today in Altium software over here. And sometimes you want to write down something on your PCB, you are going to click on this one. This is a place string. So when you click on this string, this on like this, and when you are going to click on this string, double click on this one, you can write anything. Since I have made this PCB, so I am going to call it my name over here, or maybe not even my name, I can call it a 7 segment with dip switch. So this is a quite long name, but anyway, I have just tried to put that name over here. Now one thing very important, since this is your first time you are doing this one on your Altium software, for your week you have to design this same PCB on your computers, save that file, and Sir Bilal will actually tell you how you are going to actually submit that file. We are going to give you some Google Classroom links or whatever. So, but whenever you are designing that PCB, instead of writing apart from that 7 segment with dip switch, write down on that PCB your name, supposedly your name, just let me write it down, my name over here, and with that name write down your roll number also. So maybe let me just write down any name number. This is 2020 EE / some roll number XXX. So that is the over here. So when you are going to submit your PCB design, whatever that design may be, it can be the same exact copy of this one or maybe a different orientation or whatever, but your first assignment for this week is that you have to design this same PCB in same over here using this 7 segment, a dip switch, resistance over there. Now one thing more, I used a fill area over here. Another reason of using a fill area can be this place over here like this, because it is handling a large amount of current. Using a fill area means that it is complete with copper. So it can handle a large value of current. Since all of these 8 wires, the current is actually going to sink towards this connector. So it's better to use the fill area because all of them are ground. So it's better. So this is the PCB design single layer of this circuitry which we have just done today with block connectors. Block connectors are not available in this Breadboard, but this over here is giving you that dip switch, 7 segment and 2 block connectors over here. Gee, any questions from the audience, please? Gee, any questions over here? Roll number 23, you please turn off your camera. I don't know why you have turned on your camera. Gee, any questions? Gee, beta, libraries will be provided. I'm just going to give that zip file to Sir Bilal and I will upload them on my website also, so don't worry. ये अभी बेटा मैं अभी कर देता हूँ. I'm just going to click